Alright, hey guys, no joke today, let's just get right into it. I realize that some of us need to like brush up on this difference of squares thing, which is something from Algebra 1 that they've covered, but I guess something that we should review again. Alright, so what the difference of squares is that if you have something like x squared minus 4, this actually breaks apart into x plus 2 and x minus 2. And you can do that using x box factoring, or if some of you guys are good at the guess and check way, that works as well. If we did an x box factoring, it would be like this. X squared times negative 4, that's negative 4x squared. Underneath there's no middle term, so I need two things that add up to 0 and multiply and give me negative 4. So that's positive 2 and negative 2. And then if I put it into a box, it would look like this. I would have x squared, negative 4, 2x, and negative 2x. That would give me x plus 2 and x minus 2. Okay, so x box factoring would have worked as well. Now, it's a specific type of situation where you have a squared minus the b squared, and it's that you will get a difference of squares. In other words, you have a square minus a square, a difference of square. So that gives you this sort of situation. You will always take a plus b and a minus b. And if you remember from our imaginary numbers and complex number stuff, we typically wanted a difference of squares because we wanted to create the conjugate, which would be the difference of squares, and then it would get rid of the middle term. Notice that these middle terms always get removed. This 2x and this negative 2x. Alright, and the same thing would happen if I did these two and I did an area model. I would get x squared, 1x, negative 1x, and negative 1. Right, negative 1 squared, which would still be negative 1. Okay, so that would be x squared. These two would get cancelled out, and then you would have minus 1. And that would be the difference of that square. Okay, so just in case you forgot, that's the difference of squares. Alright, what I'm going to do now is clear this off. And let's talk about the next thing, which is the difference and sum of cubes, which is SOAP. So for example, I'm going to show you two examples here. You always want to have some sort of a to the third power, and it's either going to be plus or minus, and I'll just keep it plus b to the third power. Okay, and the other one will be a to the third power minus b to the third power. Now before it was a difference of cubes, or sorry, difference of squares. In other words, a squared minus b squared. Now because it's a cubed, you are given two different things here. You can have a positive or a negative. Okay. Now if you have this, you should get SOAP. Okay, and you can always follow SOAP. So it's always a and b, and it's a binomial. And then you should have a squared, ab, and then b squared. And same thing over here. A squared, ab, b squared. Alright, with SOAP, this is what it does. It tells me that's always the same sign. So what's the same sign here? It's positive. Same sign here. It's negative. Opposite. So the opposite of positive would be negative. Opposite of negative would be positive. Always positive. And the last part's always a plus. So that's how it's going to go. Now, if we have this example here, and this is what I want you to put down, a would be, if we had a to the third power minus 27. Okay, so this is the tricky part, is that this always wants to be a cube. You always want this to be a cube. Otherwise, it's not going to work. Okay. Now in this case, this really is a cube. This is the same thing as a to the third power minus 3 to the third power. Right? 3 to the third power is 27. Okay, so what we really have here is a to the third power minus 3 to the third power. So we're going to do SOAP to it. We're going to put everything in like we need to. We know that we can factor this out using SOAP, and that would be a, and then what would be b? B would be 3. And you have a squared, and then a times b, which would be 3a. And then lastly you have b squared, which is 9. And then all I have to do is follow SOAP. Same, opposite, always positive. So the same will be negative, because it's a negative right here. Opposite, positive, and always positive, that's positive. Okay, and that's SOAP. So essentially you can break down any sum or difference of cubes. And we could do the same thing if it was something like this. A to the fourth plus, let's do to the power of, let's do 4 to the fourth power, so that'd be 1664. Oops, and let's actually change this to the third power, sorry. Plus 64. Okay, I know that breaks apart into a to the third power plus 4 to the third power. And I can do the same thing again. A, then I put b, which is 4, a squared, and then a times b, that would be 4a, and the last thing would be b squared, which would be 16. Then I just follow SOAP, same, which would be this whole thing, which would be positive, opposite, which would be negative, always positive right here, and that would be positive. Okay, so that would be the key difference here, is how they look, how the SOAP would change. The main thing is this term changes, and this one changes. Right? It's always same, opposite. Okay, so let me set up my next example here. Synthetic substitution versus grouping. This is something Margaret brought up in class, is that synthetic substitution and grouping. Why do I have two different things? Well, in synthetic substitution, and I guess in this case it would be division, we want to check to see if the factor is really a factor, and they'll break it apart for us. Whereas what you could do is you could continually do synthetic division and check to see if things are factors, but that will take a long time because you don't necessarily know it's a factor, right? If I said find the factors for this, you don't really know what you want to divide by yet, right? You might take a guess, like maybe like x plus 1 or something, but you don't know for sure that that's what you want to check. You could check it and you might get a remainder that's not 0, so you would know it's not a factor. So let's look at this one. Is x plus 4 a factor of x to the third power minus 6x squared minus 16x plus 96? Well, this is screaming a synthetic substitution, or sorry, synthetic division, because it's saying check to see if it's a factor. So let's see if it's a factor. So we have x to the third power minus 6 minus 16x minus 6x squared minus 16x, and then plus 96. And I want to check to see, I want to check to see that x plus 4 is a factor. Okay, so I'm going to do synthetic division. That's going to be this, which would be, first off, it would be negative of whatever that is. Then you put down the coefficients. There's a 1 in front of the x to the third power, a negative 6 right there, a negative 16, and then a 96 over here. This is going to drop down. I get 1. I have to bring it back up. 1 times negative 4 is negative 4. Comes back down. Negative 6 and negative 4 give me negative 10. comes back up, that gives me positive 40. Add those two together, I should get 24. I multiply this times negative 4, and I think that's 48, that's 96. So it should give me negative 96, and that gives me a 0 remainder. That's the wrong color. 0 remainder. Okay, so yes. Okay, since this is the remainder, x plus 4 is a factor. Okay, now what we can do from this is we also know that it factors apart into x plus 4, and we should even break this part down. Well, I know this is the constant term, this is the x, and this is the x squared. Okay, and this should be a positive 24. So I know what the other factor is. This is the x squared minus 10x plus 24. Alright, now we could say we're finished here, but we can even break this apart even further. Is that now that we have an x squared here, we can even use x box. And if we used x box, we would get x minus 6 and x minus 4. Right? So see how this actually could be broken up by x box. And I'm still left with the factor here of x plus 4. So in this case, we were able to factor everything out. We checked to see that x plus 4 is a factor. Yes. And then we ended up with the x squared minus 10x plus 24. And then we said, well, we're going to x box that and get the factors of that. So these are the factors. Now if I was to graph this thing, I could even see what the zeros are. The zeros are negative 4, positive 6, and positive 4. Remember when we did x to the third power, so either like this or they're like this. So we know that we have something that looks like this. It goes and hits it at negative 4. So we'll say somewhere over here, positive 6, and somewhere over here, and somewhere over here. That's positive 4. And then we have our thing, which is a cubic, so it goes up and down like this or this. But we look at the leading coefficient here, and it's positive, so we know that the right should be upwards. Right? It's going upwards, because as we go positive, it's still positive. And of course, because it's 0, it has to go like this. And we know that because it's going downwards to negative, it's going like that. So we know it should look something like this. See how I like these Christmas colors? Very cool, huh? Alright, so that's the idea, is that we've done all these things. We now know where the zeros are. We know what the behavior is going to look like. The factors give us the zeros. That's what we're going to go into more next. And that gives us a lot about things. Now here's the last thing. Let me pause it so I can set it up real quick and save time. Okay, so let's do this one. X to the 5th power plus 2x to the 4th plus x to the 3rd plus x plus 1. And I think this is the one that either Amelia asked me or Shane asked me, or maybe it was Margaret or Charlotte. But if I had an odd amount of terms here, would I still be able to do grouping? And the answer is, it's not likely that anybody's ever going to ask you to group and have an odd number of terms. It's mostly always even. But is it still possible to do it? And I think the answer is yes. So you guys kind of threw me off a little bit, but I made up this example. X to the 5th power plus 2x to the 4th plus x to the 3rd power plus x plus 1. And what I'm going to do is I factored it into this. I have x to the 3rd power here because I pulled it out and I left that. Then I have x plus 1 over here. From here I said x squared plus 2x plus 1. That's the same thing as x plus 1 times x plus 1. And I have x plus 1 here. So what I'm going to do is I'm going to factor out an x plus 1 from both of these. I have x plus 1. And then that should leave me with, multiplied with x to the 3rd power times x plus 1 plus 1. And in this situation it would leave me with x plus 1 times, I'm going to multiply back in, x to the 4th plus x to the 3rd plus 1. So I did factor something out in this case, in x plus 1. And I know what my two factors are, x plus 1 times x to the 4th plus x